This year we have an FRQ on particle motion. So since we didn't have one last year, it's really good news. This is a calculator active exercise, one of the two calculator active FRQs, and we can see right away that the equations for the velocity are pretty complicated. Chances are we can't integrate that, and we need to know how to use our calculator. So let's read the general information quickly. Particle Q moves along the x-axis so that its velocity at any time t is given by this function. The function is v sub q of t, and that's interesting. It's not just v of t, and the reason is there's going to be another particle later on in the exercise, particle r. So to distinguish whether we're talking about the velocity of q or the velocity of r, we write their velocities like that, v sub q of t, and then there's going to be a v sub r of t. This is the position x sub r of t, etc. So make sure that you use these notations when you discuss the position, velocity of acceleration of particle q or r to make it very clear what you're talking about. Its acceleration at any time t is given by this function a sub q of t, and the particle is at position x equals 2 at time t equals 0. So a, b, c, d, we have to divide 9 points among these 4 questions. Let's jump into question A right away. In the interval between 0 and 5, when is the velocity of particle q increasing? Give a reason for your answer. Given that we have our calculator, we might as well graph these two functions. Here's v sub q of t, and here's a sub q of t. So we have to be careful. We are only focusing on the interval 0, 5, so we will only look from here to here, and on the acceleration graph from here to there. So when is the velocity of particle q increasing? Let's look at the answer from student A. V sub q of t is increasing on the interval 0, 3.963 because the acceleration is positive. That's a perfect answer. We can see here from 0 to 3.963 the acceleration is positive, and therefore the velocity is increasing. It is good to have an explanation that uses the acceleration because we want to be talking in calculus terms here. If you gave this question with a graph to a pre-calculus student, they could certainly answer that the velocity is increasing from 0 to 3.963, but they would only be looking at the curve going up. So we want to talk in calculus terms, something that distinguishes what we've learned from pre-calculus material, and therefore we say v prime is positive, which in this case means a is positive. So the answer earns 1 point for the correct interval and 1 point for the explanation. One more note, because here 0 is not included, it is good to put an open interval, and on the other hand here it depends kind of on which textbook you read, whether 3.963 should be an open interval or a closed interval, and AP accepts both cases. But here they should not accept both cases because 0 is clearly not in the interval. Student B gives the following answer: increases on the interval x equals 0 to x equals 3.96 because a of t, which is v prime of t, is positive here. It looks perfect, and in many situations this would earn 2 points, but unfortunately, as you can see, that student did not give 3 decimals, only 3.96 and not 3.963, and therefore they did not earn the answer point. Their justification, however, is correct. Student C looked at intervals. Apparently this is where the acceleration is positive, this is where the acceleration is negative, so the answer is in the box from 0 to 3.963 because a sub q of t is positive. So the answer is correct. The explanation is correct. It's minimal, so I would recommend you make a little bit more effort to earn that second point. But here the graders were generous. Question B, find the position of particle Q at time t equals 3. So when we look at the answer from student A, this is all that student A wrote. And I want to go back to why this is true, and we want to look at the fundamental theorem of calculus. If you have a function f and you integrate from a to b, then that is equal to the integral of f at b minus the integral of f at a. This is something you all know. In this particular context, we have a velocity function, and we are integrating from 0 to 3. So why 0 and 3? 0 because we know the position of the particle at x equals 0, at t equals 0, at t equals 0, x equals 2. And why 3? Because 3 is what we're looking for, so we want it to be part of the equation so that we can solve and find the value. So here instead of f we have v. When we integrate a velocity we get a position function, so x sub q of 3 minus x sub q of 0. From here, if I add x sub q of 0 on both sides, I get x sub q of 3 equals this. And this is what that student wrote. I aligned it. X sub q of 0 is 2, and then this here using the calculator can be found right away, and the answer is negative 1.49. So it looks like here we only have 2 decimals, and we just saw an example of a student losing a point because of not writing the correct answer to 3 decimals. This student, however, earned all 3 points. So what happened? Well, the answer is simple. The answer to 3 decimal is negative 1.49. Negative 1.490, but this is the same as negative 1.49. It's not lucky. The student knew exactly what he was doing. Again, in terms of notations, I would really recommend that you write x sub q of 3 equals this equals the answer. It's just good math. Student 2, exactly the same thing and exactly the same answer, same number of points earned. Student 3 gives an answer only, negative 3.4901. This is 0 points, 0 points, there's no explanation, and the student shows no work. It seems pretty obvious that the student integrated. Let me just go back. The student integrated this and found negative 3.49, but just did not add 2. So it's a lot of points lost for a tiny mistake. If there was just a 2 plus this, the answer would be correct. But yeah, you should write explanations, you should show your work. Showing work is always very important. Question C. A second particle r moves along the x-axis so that its position at any time t is given by a differentiable function x sub r of t, where at time t equals 1, x equals 4, and at t equals 3, x equals 8. Explain why there must be a time t between 1 and 3 at which the velocity of particle r is 2. The answer from student A uses the MVT, and that's perfect. So the student notices that if he does rise over run with the 2 points that are given, he finds that the slope of the secant is 2. And given that the function is differentiable, we can apply the MVT, and the MVT guarantees that there is going to be a point, a place, so a time t here, in the interval 1, 3, where the velocity is equal to the average rate of change. So nicely done. It's great to mention the MVT. The student doesn't say that the function is differentiable, but if you name a theorem, I believe you don't have to explicitly say what the conditions are. If the student wasn't sure what theorem it was, you can alternatively name all the conditions and say that there is a theorem that guarantees, etc., etc. Just a comment about notation here. This student earned all points, but the math is not great again. The MVT guarantees that this E backwards means there exists, guarantees that there exists a value t included in the interval 1, 3, so this is a part of, and this, I guess the student think it means such that, but it doesn't, so not great. I would recommend you just write using English words, but the graders were lenient, and the student got 2 points. Student B, same thing, uses the MVT, finds the slope of the secant between the 2 points 1, 4 and 3, 8. Because of the MVT, there must be a time t at which x prime sub r prime of t equals 2. So simple explanation, not a difficult question really. Lastly, student C says, there must be a value at which x sub r of t has a velocity of 2 because the estimated velocity is exactly 2. We can see here that the intention of student C is correct. They find that the average velocity is 2, but they use a wrong term, the estimated velocity, that's unrelated, and therefore one of the 2 points was not earned. Finally, question D. This is a good question. It's a little bit tricky, but once you think about it, it makes total sense. So it's worth listening to this question, and always be ready for question D that's a little bit outside the box and requires to just think about the case and not just try to remember how we did that in the past. At time t equals 3, the velocity of particle r, described in part C, is negative 2. Are particles q and r moving towards each other or away from each other at times t equals 3? Explain your reasoning. Student A wrote all the information here in this like 2x2 matrix. The velocity of particle r is negative 2 and its position is 8. The velocity of particle q is 1.68 and its position is negative 1.49. Now the student put all that information on a little sketch. So because particle q is at negative 1.49, she put it here, and because particle r is at 8, she put it over there. And now these little arrows show the velocity, so particle q is moving towards the right, and particle r is moving toward the left. And therefore, the student concludes, yes, the particles are approaching each other. So this is perfect, correct answer, and here we can really see what the student did and how she reached that conclusion. Student B finds the velocity of particle q, writes the velocity of particle r, and then just looks at these two numbers, sees that q has a positive velocity and r has a negative velocity, and jumps directly to the conclusion that they are moving away from each other. So let's see a little graph here. It seems like the student is simply assuming that if the velocity of one particle is positive and the other particle is negative, they are automatically going in an opposite direction, which they are. But it doesn't mean they are moving away from each other. This is the actual situation here. Q is indeed going toward the right, R is indeed going towards the left, so they are moving in opposite directions, but that means they are getting closer and closer. So that was clearly a nicely planned trick from AP, because I think many students must have not realized this little detail. And by the way, the student earned 0 points because it didn't matter what the explanation was. As soon as the answer moving away from each other was wrong, the student couldn't earn the second point. Finally, student C makes the same mistake as student B, compares the two velocities, notices that the particles are going in opposite directions, and concludes that they are moving away from each other. So 0 points. That's it for this second FRQ about particle motion. I hope it helped. Thank you for listening.